Assalamualaikum and good day. This topic is about the Niosh 1991 recommended weight limit. My name is Ezrin, your course coordinator. To determine the recommended weight limit, or we call it as RWL, ergonomists use Niosh lifting equations. Niosh lifting equation is a mathematical equation used to determine or calculate the RWL. RWL is equal to LC multiplied with the HM multiplied with the VM multiplied with the DM, EM, FM, and CM. In the next slide, we will have a look at the definition of each acronym listed in the RWL equations. Meanwhile, Li is equal to lifting index. How to calculate the lifting index? Okay, lifting index can be obtained by the object weight divide with the recommended weight limit. So let's go to the next slide to see how the Li is function to determine the safeness of the lifting activity. Recommended weight limit and the lifting index can be used as a design aid to compare job designs or to prioritize tasks for redesign or to set maximum loads if task variables are fixed. Alright, before we decide to use the Niosh lifting equation to identify the recommended weight limit, we need to ensure that the situation is as follows. First, the given load is static load. No increase or decrease the load in the middle of the job. The burden lift with both hands. If the lifting activity is not allow you to use your both hand, meaning that you only need to use one hand, so the Niosh lifting equation cannot be applied. You need to use another method of assessment to conduct the assessment regarding to the lifting activity. The appointment or drop objects made within a maximum of 8 hours. The appointment or drop objects cannot be done while sitting or kneeling. The workplace space is not narrow. To have more understanding on what situation are suitable to use the Niosh lifting equations, let's have a look at this slide. Niosh lifting equation does not apply if any of the following occur. Lifting or lowering with one hand, lifting or lowering for over 8 hours, lifting or lowering while seated or kneeling, lifting or lowering in a restricted workspace, lifting or lowering while carrying, pushing, or pulling, lifting or lowering with wheelbarrows or shovel, lifting or lowering with high-speed motion, which is faster than about 30 inch or per second, lifting and lowering with unreasonable foot or floor coupling, lifting or lowering in an unfavorable environment such as temperature significantly outside is so extreme, all right, and so on. Here are the details of the terms that used to calculate the recommended weight limit. RWL is equal to recommended weight limit. LC is equal to load constant, which is in kilogram. We use 23 kilogram. HM is the horizontal multiplier. VM is the vertical multiplier. The DM is distance multiplier. EM asymmetry multiplier. FM frequency multiplier. CM is equal to coupling multiplier. To obtain the value of recommended weight limit, each of the assessor need to identify each of parameter that's stated in this slide. And by by knowing the value of the multiplier. Okay, I will teach you how to obtain those values so that the RWL can be obtained. As I did mention about all the value need to be obtained so that the RWL can be calculated. So it is very important for us to really understand the meaning of the parameter so that we can calculate all the parameter correctly. Now here we can see the definition and the measurement of each parameter in the RWL calculation. Lifting task. Alright. As per mentioned in the previous slide, lifting tasks can be calculated using the RWL calculation or Niosh lifting equation as long as the situation is allowed as per shown in the previous slides. Okay, so the lifting task is defined as the act of manually grasping an object of definable size of mass with two hands and vertically moving the object without mechanical assistance. So before you can conduct the Niosh lifting equation, you need to observe whether or not the lifting task is is comply with the definition. All right, you need to know the kilogram of the object, the weight of the object, and make sure that you only can move the object vertically without mechanical assistance, without hoist or conveyor or whatsoever. All right, load weight L. Weight of the object to be lifted in pounds or kilogram, including the container. So in this case, we use kilogram. All right, including the container. You don't have to separate or to estimate the weight of the container and try to put aside only to focus on the weight of the goods that you are handle. It's not, don't have to do like that. Okay, and then the horizontal location. Horizontal location is the distance of the hands away from the midpoint between ankles in inch or centimeter. So in this case, we will use centimeters. All right, I will show you the picture to give you a clearer visualization about the horizontal location. And vertical location is the distance of the hands above the floor in inch or centimeter. Measure at the origin of the goods. You need to lift the goods to another level of height, for example. So we measure from the origin of the good to the destination of the good to be lifted. We continue to the definition and the measurements. Neutral body positions. Neutral body position describe the position of the body when the hands are directly in front of the body and there is minimal twisting at the leg, torso, or shoulder. Lifting frequency is defined as the average number of lift per minute over a 15-minute period. Lifting duration, three-tiered classification of lifting durations specified by the distribution of the work time and recovery time, which is we call it as the work pattern. Duration is classified as either short, which is 1 hour, moderate duration, which is 1 to 2 hours, or long duration, we consider as 2 to 8 hours, depending on the work pattern. Coupling classification is referred to the classification of the quality of the hand to object coupling, example handle, cut out, or grip. Coupling quality is classified as good, fair, or poor. The significant control is defined is defined as a condition requiring precision placement of the load at the destination of the lift. This usually the case when worker has to regrasp the load near the destination to the lift, or the worker has to momentarily hold the object at the destination, or the worker has to carefully position or guide the load at the destination. This slide is showing the graphic representation of hand location. By looking at this picture, you can see the midpoint between inner ankle bones, which become the starting point. The horizontal location is measured. The measurement of the horizontal location is at central of the box, whereby the placement of the lifter hand while conducting the lifting activity. To recap, horizontal location is defined as the distance of the hands away from the midpoint between ankle, measured at the origin and the destination of the lift. Meanwhile, the vertical location is the distance of the hands above the floor, as can be seen clearly in the picture. In this slide is showing the RWL parameter and the calculation to obtain the multiplier for each parameter. For load constant, we will use 23 kilogram. We will focus on the metric, alright? So for horizontal, vertical, distance, and asymmetry multiplier, there are a calculation that we have to use, alright? Meaning that after we obtain the value of horizontal, vertical, distance, and asymmetry, we need to insert in the calculation to obtain the parameter multipliers. Except for frequency and also coupling, we will use multiplier table. In the next slide, I will show you how to use that table. In this slide is showing the position measurement. As you can see, there are HO. HO is stand for horizontal origin, and HD, horizontal destination. Also have vertical origin, which VO, and VD is vertical destination. W is the weight of the goods, alright, the weight of the goods that need to be lifted, and also the picture also showing how to measure uh, the the middle of the ankle for both feet. All right, let's have a look one by one of the parameter. For this slide is horizontal multiplier. As you can see, to obtain the RWL, we need to have the HM. HM is horizontal multiplier. Before we can have the value of the horizontal multiplier, we need to have the value of the H to be inserted in the calculation of the HM, horizontal multiplier, as I write in this slide, in the red color. Alright, so if we are talking about the horizontal, so there are two horizontal values that need to be paid attention, alright, which is HO and HT. You may have a look at to the arrows that pointing to the value of the horizontal, and after you get the value of the horizontal for both, horizontal origin and also the horizontal distance, you may put in the calculation. This slide is showing the horizontal multiplier graph. If you get the calculation, you don't have to use the graph to obtain or to calculate the horizontal multiplier. But in this graph is showing that if your H value is less than 25, you can simply put the horizontal multiplier as 1. But if the value is greater than 25, and you have to put in the calculation to obtain the value of the horizontal multiplier. Same goes to the vertical multiplier. We need to obtain the value of vertical, and as you can see from the arrows, I also provide arrows to point out the vertical origin and the vertical destinations. After we obtain the value, we can insert or put the value in the calculation of the vertical multiplier. This is the vertical multiplier graph, and I will not discuss further about the graph, as we can use the calculation to obtain the vertical multiplier. dm is the distance multiplier. The distance is the vertical travel distance in centimeter between the origin and destination of the lift. We can simply get the distance value by having the vertical destination and the vertical origin. So we have to minus the vertical destination with the vertical origin. dm is account for metabolic demand, thus dynamic but not lift versus lower. Here is the distance multiplier graph for your reference. For a symmetric multiplier, we need to get the A, which A is actually the angle in degree of asymmetry, angular displacement of the load from the sagittal plane, measured at the origin and destination of the lift. After we obtain the A or angle of the movement during lifting, hence movement during lifting, and also the torso movement, we have to insert the value of A in the calculation of asymmetry multiplier. Here is the graph of asymmetry multiplier for your reference. This slide is showing the frequency multiplier. The frequency of lifting and the duration of lifting in minute or second over a work shift need to be obtained to identify the frequency multiplier. If you can see in the first column of the table, the frequency of lift per minute, meaning that you need to identify the frequency of lifting that being conducted in minutes. So if you obtain the value of the frequency, you may circle the frequency of lifting per minute at the first column. After you obtain the value of frequency lifting per minute, you need to assess whether the lifting activity is conducted less than 1 hour or less than 2 hours but more than 1 hour, or more than 2 hours or minimum 2 hours but less than 8 hours. So there are three duration of exposure need to be considered. After that, you need to know the height of the lift activity, meaning that you need to know the vertical value for lifting activity. If the lifting activity is conducted less than 75 centimeter, so you use the V less than 75 centimeter. If not, maybe the lifting activity, the load need to be lifted more than 75 centimeter, or at the minimum 75 centimeter. So you need to use the column of the specific value of the vertical more than 75 centimeter. So each of the duration of lifting, there are three duration of lifting, short duration, medium duration, and long durations. So you have to be specific in terms of the vertical distance of the lifting activity. So by having that, you know where is the column that need to be focused for each activity, each for each different duration will have different frequency multiplier. In this slide is showing the coupling multiplier. Coupling is have three types, which is good, fair, and poor. For good coupling, the coupling is having handles or object that can be comfortably grasped. Meanwhile, for fair coupling types is less than optimum handles or load contact by finger up to the palm. Meanwhile, for poor coupling types, the lifter need to manage a bulky shifting sagging load or load with sharp edge, so that is so difficult to be handled. However, not only that to consider while determining the coupling multiplier, you also need to have a look at to the load height. Alright, if the load height is less than 75, which is the vertical of load is less than 75, you can use the left side of the initial load coupling multiplier. Meanwhile, if the vertical load height is minimum 75 and above, so you will use the right side of the initial load coupling multiplier. On the top of that, to assess the coupling multiplier, we also can use the decision tree. Sorry. So you may start to do the assessment based on the object, whether or not the object is container. So you start with the left decision tree, the left side of decision tree. If the object is a loose object, you will start from the right side of the decision tree until the decision tree will bring you to the condition of poor, for fair, and good. Alright, now we know how to calculate the multiplier of each parameter. So by having the knowledge on the calculation of RWL, actually we are able to answer if somebody asks us about is this weight too heavy for a task, or is this weight is safe for that individual to lift for a duration of 4 hours per day, something like that. So we able to answer that questions. Lifting index, by using the lifting index, we can answer the question like how significant is the risk. If we obtain the lifting index, we can we can have a fact that or the figure to support that the risk exposed to worker is significant or not significant. A lifting index value of less than 1.0 indicates a nominal risk to healthy employees. A lifting index of 1 or more denotes the task is high risk for some fraction of the population. As the LI increase, the level of low back injury increase correspondingly. However, there is a research saying that lifting index more than 3, the stop work order need to be issued because it's too dangerous. To make the management of the recommended weight limit is simple to be managed. So the job analysis worksheet is developed so that the value of the multipliers of parameter that we obtain during the assessment, we can simply record in the job analysis worksheet. This is the job analysis worksheet. Okay, if you can see, there is a step 1, step 2, and step 3. Step 1, measure and record task variables. In the part of the step 1, there is a object weight, lifting the weight of object in kilogram, in the load average or the load maximum, the hand location in centimeter, which is it need to be put the value of horizontal origin, and V, vertical origin, the destination, destination of the horizontal destination, and vertical destination. And after that, there is a column for vertical distance in centimeter. And we also need to identify the asymmetric angle in degree. The asymmetric angle for origin, basically origin is from the starting point of the lifting. So basically the origin is 0 degree. And the destination, if there is a twisting during the lifting, so we put the asymmetric angle in degree in the column of the asymmetric angle destination. After that, we need to identify the frequency rate lifting per minute, the duration of the activity, and also we need to know the coupling, whether the coupling is fair, good, or poor. Alright. The second step is to determine the multiplier and compute the RWLs. After we obtain all the measurement from the task variable, from the recorded task variable, alright, and then we need to put all the value, we need to calculate in a different piece of paper to identify the multipliers of each variables. As you can see in this step 2, there are origin and destination. So we need to calculate the HM, VM, DM, EM, FM, and CM and obtain or find the multipliers of each parameter. But please pay attention, these multipliers, we need to focus for the origin of the load. And after that, we obtain the destination of the load, the last destination of the load that lifted. Alright, and then we will get the RWL for each origin and also the destination. After we obtain the RWL for the origin and destination, we go to the step 3 to compute the lifting index. Alright, we came to the end of the lecture of the Niosh lifting equations. So here is the tips or the additional information. A load constant is the maximum recommended weight for lifting at the standard lift location under ideal conditions. Load constant equal to 23 kilogram. Decrease the load constant to account for the influence of non-release using 6 multipliers, which are horizontal location, vertical travel distance, asymmetry, frequency, and also coupling. Need to bear in mind all multipliers are less than 1 or equal to 1. And the calculation of the RWL is as follows. Alright, this is the example of the application to conduct the Niosh lifting equations. And consider the left picture is the start of the activity and the right picture is the end of the activity. In Niosh lifting equation, we call it as origin, and the end is the destination. I hope that student may practice, use the job analysis worksheet to put all the information, and also calculate the recommended weight limit for start and also for end of the activity. After that, please obtain the Niosh, the lifting index for the origin and also the destination. Okay, I also provide the example of exercise, and basically if there is a question in your final exam or in your test, the exam of Niosh lifting equation can be into situation. For example, in this situation is in the exercise one, and also in the situation that provide with the additional of picture as you can see in the exercise 2. So for exercise 1 and exercise 2, I hope that student can conduct the Niosh lifting equation, obtain the recommended weight limit for both origin and destination, and the lifting index for both origin and destination, and submit through column. Alright, here is the other example of exercise that I mentioned. Some of the question may be assist with the picture so that student can visualize the activity, the lifting activity. This exercise too also need to be submitted in the column. With that, I think that's all for the Niosh lifting equation. If you guys have any question, you may ask me directly, or maybe can post into the WhatsApp group or any medium of communication. Okay, see you guys, and don't forget to submit the exercise within the time frame.